All right, so today you guys are going to learn about basic transformations regarding graphs. So the first one is f of x is equal to c. So this is one where you either have a vertical or a horizontal graph where you have your function equals a constant. So y, and this is just an example. So for example, y is equal to 2. This is where you're going to have a horizontal line, a horizontal graph. So this would be something like x equals 2. So this is going to cross the y-axis, and that's a constant function. So y is equal to 2. You could also have a vertical function where you have x equals a value, and then that would be a vertical equation. So this is a constant. Constant is just any number that doesn't have a variable attached to it. The next one is a linear function. You guys should know how to solve linear. And then this is just y is equal to x. So this is where you're going to use your slope and y-intercept to graph these functions. So y is equal to x, as you know, it's going to cross the origin, and then it's going to be rise over run, one up one over one. So you're going to have something like this. So this is your linear function. That looks something like so. And now you have your absolute value function. So absolute. This is the v. So you still have the origin, and then you have a v going rise over run at 1, 1 and negative 1, 1, and then it's just steps all the way through. So that's your absolute value function. So just know the three major ones are the origin, negative 1, 1, and then 1, 1. Then you have your radical functions. So for these ones, you have the origin as well, 0, 0, 1, 1, and then 4, 2, 1, 2, 3, 4, 4, 2. These are the three major points for radical functions, and then you just have the curve. Oops. When you graph functions, just know that you need to at least have at least three major points. Always have three major points when you're graphing them. So, I mean, technically for the radical, I mean, you could just write 0, 0, and 1, 1, but at least the bare minimum, at least have three major points. So this is the radical. It's also known as the square root. So function, so those, that's that function. Then now you have the parabola. Parabola. This one's very similar to the absolute value, except the only difference is that this one curves. So it's still like a V at 0, 0, 1, 1, and negative 1, 1. Just know that this one does have to curve. And then the very last function is the cubic function. So you have the x cubed. Oops. And then this one has the three major points at the origin, 1, 1, and negative 1, negative 1. And then this one curves right, center to right, and then left. It curves like a funny looking curve, I guess. These are all known as parent functions. So when it says to graph the parent function, it means to graph the function before doing the transformation. So parent, let me write it better. So they're all known as parent function. Okay, so how do you you're gonna use the following transformations. If it's outside the function and it's positive, you're gonna shift upward. If it's negative and it's outside the function, you're gonna do a vertical shift going down. If it's inside the function, so x minus c, you're gonna shift to the right. If it's positive, you're gonna shift to the left. So there's going to be horizontal shifts left and right when it's inside the function. If it's outside, it's going to shift up and down. So these are the very key notes that you need to know. And let's review because you should have all known how to graph these functions. All right, so we're going to sketch the graphs. Three functions on the same rectangular corner plane. You have f of x equals x squared. I recommend use colored pencils for this one. So f of x, the parent function will look like this at the origin. At 1, 1, negative 1, negative 1. Those are the three major coordinates. And then all you got to do is just connect the dots. That is the parent function. You don't need to have all the points accurate. At least having 3 is just more than enough because you're just going to graph these as accurate as possible. Doesn't have to be perfect. And then we're going to graph f of x equals x squared plus 2. This means I'm going to take my parent function and I'm going to shift vertically up 2 units. So that means I'm going to take my original parent function. I'm going to shift up 2 units. So at the origin, 0, 0. If you shift it up 2 units, it's going to be 0, comma 2. 1, 1. Shifting it up 2 units will be 1, comma 3. And then negative 1, positive 1. Shifting it up 2 units, we'll have it right there. And then you could just um, connect the dots. For the last function, x squared minus 2, sorry, parentheses x minus 2 squared means this is going to be a horizontal shift. And then since it's inside the function, you got to think of opposite. If it's negative 2, you're not going to go to the left. You're going to go to the right 2 units. So that means I'm going to take my parent function, not this one, the original one, and I'm going to go to the right 2 units. So at the origin, 0, 0 becomes 2, 0, 3, 1, and then 2, 1. Oh, sorry, 1, 1. And then that would be your graph for x minus 2 squared. Shifting to the right. 2 units. Anyone have any questions? What's up?
We're probably gonna have to do some of them, right?
Yeah.
Or graph them on graph. He wants to label the lines where the function does.
You could color code it.
Okay.
I recommend color coding it. It just makes it easier. Okay, moving on. Reflection on the coordinate plane. If your function is negative, it is a reflection over the x-axis. If it's inside the function, it's a reflection over the y-axis. This is very, very important, especially when we get to graphing trig functions. You got to learn how to do reflections. So be very, very careful that you know how to do reflection. All right, so for this one, it says identify the common function and describe the transformation in the graph. Write an equation for the graphed equation. This graph is not as good as I was hoping for, but based on the picture, we know it's an absolute function because it's a v. I'm hoping the one on on your homework is a lot more clear than this picture, but for this one, it looks like it's gonna go to the left 2 units. So that means it's gonna have a horizontal shift. So if I would write a what's it called, a function for this, I would have something like f of x is equal to the absolute value of x minus 2 as an example. Just know that when it comes to writing the functions, there's more than one right answer for this. Because for this one right here, looking at the picture, we know that this is a cubic function. Now, we know that this is shifted up. Sorry. Vertically shift. I'm not gonna write the whole thing. I'm just gonna write vertical. Vertical shift up. Looks like I will say 2. I honestly can't read the graph. I say it's 2. And then not only that, but it's inverted, so it's there's a reflection over the x-axis. Yeah. Or technically you can also say reflection over the y-axis, to be honest, because honestly this one has multiple answers. Because if you reflect over the x-axis, it's honestly would be the same if you reflect over the y-axis as well. So this one has more than one answer. All right, so reflection over the x-axis. So when it's on the x-axis, the negative is on the outside. So this one has, so this would be f of x equals negative parentheses x cubed plus 2. Yes, question.
Can I see the answer to example two, was something down?
Yeah, that's okay.
Although I think the. Yeah, that's, so.
What?
It's gonna be two more outside, two, no, two, example two, the first.
This one?
Yeah. It would be x plus two, right?
Oh, you're right. My apologies. I think, yeah, that's plus 2. Yeah, you're right. Sorry, my bad. See, this is where you gotta be careful because it's always so confusing when it's on the inside the function. Yeah, so you just gotta be very, very careful. All right, any questions with these ones? Okay, these next ones are honestly the most difficult ones when it comes to vertical and horizontal shrink or stretch. And it depends on the value in front of the function. So if you have a function and you have a value in this case C, if it's greater than 1, you're gonna have a vertical stretch. If the c in front of the function is between 0 and 1, so that means like 1/4, 1/3, greater than 0 but less than 1, you're gonna have a vertical shrink. If it's inside the function, if it's greater than 1, it's going to be a horizontal shrink. And then if it's between 0 and 1 inside the function, you're going to have a horizontal stretch. I would say these ones are probably the most hardest ones. So just gotta be very careful. Okay, so just know these ones are for the outside. And then these ones are for the inside. And we'll do the examples that it gives us. Okay, so for 5 and 6 is compare the graphs of the functions with its parent function of the graph. So for this one, the parent function is y is equal to absolute value of x, right? This 4 is outside. So it's outside. So that means when I want to figure out the transformation, I'm going to be looking at this one right here. Now, it's greater than 1, correct? So if it's greater than 1, what's the transformation? vertical stretch. So vertical stretch. And you can actually, what's it called? How do you supposed to stretch? Yeah, vertical stretch by a factor of 4. If you want to be a little bit more detailed. But the last part isn't really necessary by a factor of 4. If you just say vertical stretch, that's honestly more than enough, but you could be a little bit more accurate. Okay. For this one, we have a parent function, so a PF. Y is equal to X. Oh, my bad, PX. This is a cubic function. This 1/3 is inside. So I know since it's inside, I'm going to be looking at the ones right here. If it's greater than 1, horizontal stretch. If it's between 0 and 1, it's a horizontal stretch. 1/3 is between 0 and 1, so that means I'm going to have a horizontal stretch. Cancel stretch rate, stretch. This +2 is on the outside of my function. So I'm going to look on the outside, and it's going to be, it's not these ones. It's going to be, nope, not that one either. We're right here. If it's on the outside and it's positive, I'm going to have a vertical shift up that many units. So in this case, for this problem right here, it's going to be a vertical shift up 2 units. And that is transformations. Does anyone have any questions? Okay, so I actually forgot, but here's a couple of examples of what to look for when it's vertical stretch. So this would be y is equal to, so these are just examples if you would like to write them down. So y is equal to 2 square root of x. Y is equal to 1/2 square root of x. Y is equal to the square root of 2x. And y is equal to the square root of 1/2 x. So these are just examples to look for if you're trying to compare. Maybe just looking at the C is not enough. Maybe here's just a couple of examples of vertical stretch, vertical shrink, horizontal shrink, and then horizontal stretch. The reason why the negatives are not included is because from the previous examples, when it's negative, it's because it's reflection. So when we get to this one right here, so reflection over the x-axis, an example would be y is equal to the negative square root of x. And then for reflection over the y-axis, the square root of negative x. Right? So let's, if you want to see some examples. So so square root of x looks something like this. If you have a reflection over the x-axis, so I'm gonna color this one blue, it's gonna look something like this. And then if you have a reflection over the y-axis, so I'm gonna color this green, it's gonna look something like this with the parent function. So it's gonna look the other way because you're reflecting it over the y-axis or you're reflecting over the x-axis. Does anyone have any questions? It's good, because other than that, that's pretty much it. I want to say this is 2, but in my notes I wrote 4. And well, I'll say it's 2. So 1, 2, add according to my notes. So I'll just leave it this way. Any questions? Seems good. All right, other than that's pretty much it. That's so you are gonna do a lot of graphing, but not a lot of what's it called? Like math. It's honestly just telling me whether what transformations there are, what the parent functions is, and then just graphing it using transformations, using the parent functions or common functions. So not too bad. Other than that, that's pretty much it. All right. So for your homework.